Hey everybody, Chris here from It's Mead Made, and today we are going to be talking about the speed settings in Bamboo Studio. So let's not waste any more time, get into this video. So before we get started, I just wanted you to see what version of Bamboo Studio I'm actually running. It's version 1.7.4.52. And this is the most up-to-date as of today. So let's go ahead and close this. We are going to get into the speed settings. And if you look here, we don't see speed anywhere. Nowhere in any of these is speed. And what we've got to do is we got to go into our advanced settings. Now, all you have to do is come up here to advanced and just toggle that button. And if you notice, now we actually have some more settings here. And if you look right here, speed. Now, this is where we can adjust our speed settings. Now, I am not going to cover everything here, but generally speaking, I can tell you that this is the speed settings for our first layer, all our other layers when it comes to our 3D prints, and our travel speed, which means that is when the nozzle is actually moving and it's not actually printing. And then the acceleration, which is the speed of which it jumps into the next thing that it's printing. Now for this video, I am going to be talking about our first layer speed and other layer speeds. And we're really just going to be talking about this section right here because this is the most important for you to understand, especially if you're new to 3D printing or new to this software. So the first thing is our first layer, and that is exactly what it sounds like. This is all of the settings when it is all about our very first layer. Now on the Bamboo printers, they print by default at 50 millimeters a second when it comes to our very first layer. And that is one of our most important layers. So the one thing I can absolutely advise you is you never want to increase this, but you can decrease this. Now, for those of us that are coming from more traditional 3D printing, like 15 millimeters or 20 millimeters a second is usually what you do for a first layer. But this actually does really good for 50 millimeters a second. I have only had one or two issues with some very intricate 3D prints for the first layer that I actually decrease this just to make sure that I can get a good bed adhesion when it comes to my first layer. But for the most part, all of the other prints I've done, 50 works really nicely. Then we have our first layer infill, and this is the very first layer of infill it's actually drawing out inside your model. Now the reason that this is a little slower is we want to make sure that we have a really good adhesion to those bottom layers of our 3D print. Because if you get a really poor adhesion to your infill, depending on the infill you're using, I tell you what, you can get some problems, especially if you're using something like concentric, where it never actually touches the outside shell of your 3D print. So if it gets knocked off or something like that, that's not a good thing. So having this a little bit slower is also very beneficial. Now 105 millimeters a second is a pretty good speed. Now I would not advise going over that, but that's just my personal preference. I think this is a very good speed, and I've never noticed any issues in all of the prints that I've done on my printer. Alright, so now we have our other layer speeds, and before we even get into these, I'm going to go ahead and slice this. And this model is actually by SparkyFace5. This is a cute little Pokemon Sandshrew sleeping, and I just thought this would be kind of fun to kind of print, so I am going to use this as our example today. So I went ahead and sliced this just so we can get a better idea of what all of these things are. Now the great thing about Bamboo Studio is all of the color coding, and if you're not familiar with the color coding, right here is a nice reference to even show you every single thing that is actually printing. Because there are different types of things it's actually printing, like the infill or the outer walls or inner walls. And if you look right here, you can see inner walls are yellow, outer walls are orange, obviously, because we can see all of this orange right here. But all you have to do is use this as a quick reference. If you ever have any questions of like, okay, what is this printing or what is this speed? The best thing you can do is honestly slice it, look at this diagram, and then just slice through your model, and then you can see what it's talking about. So I'm going to go ahead and zoom in real close here just so we can see on the outside. Now, first over here on our left, we have our outer wall speed, which is at 200 millimeters a second. And if you look here, this is orange. So this is the outermost layer of our 3D print. And this one is the one that really you need to focus on. Because if you're having some issues with your 3D prints and the outside just looks like, junk, maybe you're actually printing it too fast. And you need to slow it down. But at 200, I have found that the Bambu printer just does amazing with. Now, depending on the prints, I will come in here and I will mess with my outer wall speed if I want it to go faster or if I want to slow it down, because there is a lot of intricate pieces and parts when it comes to my 3D print. So this is our outer wall. Now, next we have our inner wall. And this is in yellow. So you can see this right here. This is our inner wall. And if you're wondering, if you actually go over here to your strength, you can see wall loops. And right here it says 2. This is the amount of actual wall thickness you have. So this is actually at a 2 loop thickness. So if you are familiar with any other slicing software, this is usually your wall count. But they call it loops in Bambu Studio. So jumping back here, then we have our sparse infill. Now our sparse infill is just a fancy word for our infill. And you can see it right here. Sparse infill is this kind of maroonish kind of red. Then the next one is our internal solid infill. And that is this purple right here. You will typically see it along the walls and the edges when it needs to give a little more of an infill to accommodate for the next layer, so it's actually printing on something. Now, this is at 250 and your sparse infill is at 270. Now, these are things you can definitely adjust, but 270 and 250 are actually really good speeds. This is the thing about Bambu Studio. Unlike other slicers, this slicer is specifically designed for Bambu printers. And I tell you what, they have honed this stuff in. This is where you can get the least amount of failures and the fastest amount possible. I'm not saying that you can't increase this a lot if you wanted to. You absolutely could. But the faster you go, the more of a risk you have when it comes to getting a failed print. So just let me say that to you. Now the next one is our top surface. And our top surface speed is exactly what it sounds like. It is the very top surface of our 3D print. So at the very top of every single point of your 3D print, this is the speed that it's going to be. And typically, whatever your wall speed is, this is what you want your top surface to be as well. Because the top surface is also a part of your shell, the outermost part of your 3D print. So if you're printing at a 200 millimeter speed, then you can go at a top surface speed of 200 millimeters a second as well. So your outer walls and your top surface, they should be pretty much the same. Now I'm going to go ahead and skip down here to bridge. And what your bridge is you can honestly think of this as the same thing as your internal solid infill. But that is along the edge when it comes to your internal solid infill. Your bridge actually will infill certain areas to accommodate the next layer, to make sure that it's actually printing on something. And it's usually on the inside of your prints. And if you see here, this blue right here is your bridge. So it's actually creating these little platforms for the next layers to print onto because of this harsh plateauing of each layer, and you can see that here. Now you might notice you will see a lot more of bridging in your 3D prints if there's a lot of subtle gradations or if your layer height is a lot thicker. Then you have your gap infill, and what this does is this essentially just fills in any of those bigger gaps that aren't your internal solid infill or your bridge or anything like that. And you can actually see that right here. That is the white. So when you see all of these little white pieces right here, that is actually your gap infill. So the big thing here is it needs to know these speeds so it can jump to those speeds and accelerate to those speeds when it gets to those certain sections. And the important thing to really understand is it doesn't just print this stuff like one at a time. It prints everything at once and it jumps to those different speeds each time it hits one of those specific things like your sparse infill or top surface. So I'm going to go ahead and play through this and you can see. Now the first thing it does is the inner wall, and that is giving it something for the outer wall to actually bond to, and this really helps with those overhangs. And it's important to understand these outer walls. But if you also look that this outer wall right here, it actually didn't get it right up against it, because that is determined by what the other things are too that it could possibly be attaching to. So if we keep going, we can see it starts the infill. So after that, it starts in on the infill, but then it does the sparse infill. And you can see all of the sparse infill that it actually starts to create. And along the way, it's also filling in. So you can see right here, it's actually filling in those gaps where the gap infill is. Then when it's done with that, it does the internal solid infill. So it does those things right there, but then it determines it's actually faster if it goes back to doing infill. And you can see there are certain things that it does each time it gets to one area. So it essentially uses the infill to jump to different parts of the print to do all of these other different things, like the internal solid infill, the sparse infill, and the bridging and the gap infill. Now, you might be wondering why you need to even know this. Now, you might be wondering why I'm even showing you this. I think it's super important to understand how your 3D printer is actually printing. Because when you get certain issues, and let's say that this looks super rough, like right here where this plateau is, so you would know that this is actually my sparse infill. So I would know maybe I'm going a little too fast. Maybe it's not looking that as good as it needs to for this. So I need to slow it down. Or maybe it's your outer wall that is just, you know what, you're starting to miss this detail. And maybe you're going too fast. And honestly, maybe you can see that everything's looking good and you can kind of test it and go a little faster. See how fast you can actually go before things start to mess up a little bit. So that's everything you really need to know when it comes to your infill speeds. Now, when it comes to these speeds, I think the Bambu printers print really fast, and these default settings really work well. Now, I'm not saying that I don't ever change these, because I definitely do. But if you're just starting out, leaving these are just fine. But if you're really wanting to start pushing your printer and seeing what it's capable of, try to increase some of these speeds. I recommend starting out with the inner and outer wall speeds along with the top surface. But just remember, match your top surface speed with your outer wall speed. So now let's jump up here to slow down for overhangs. Now this one, I tell you what, this is a super cool feature. But you need to understand this feature and how it works, because there's sometimes that you might not want this, and this is default. So first you're going to notice there's these 4 numbers right here, and then there is these percentages right here. Now, these are percentages between, so between 10% and 25%, between 25 and 50, 50 and 75, 75 and 100. Now, I'm not going to lie, this took me a while to wrap my head around, just because this is actually looking at your angles. So the big thing here is, if you think about this, anything between 10 to 25% is almost completely vertical, and anything down here at 75 to 100%, they're the ones that is down here in blue, to where these really need support and they're coming out really far. And this is where it needs to slow down. So this is the whole thing. This is just the percentages of in between these different values. Because the blue here is actually our overhang walls. So you can see that these are actually overhanging. And they're overhanging quite a bit. And to kind of help you understand the slowdown, if we come over here to to help you understand a little more of how this is actually working, I can come over here to this little drop-down box where it says line type, and I can click on speed. Now, with speed here, we can see that there are different colors now, and that is what this is. Our overhang speed. It is actually slowing down for overhangs. And if we look here, we can see that right here, we've got pink, so that's going about 37. Then we've got a really bright pink, which that's going at 10 millimeters a second. Then we've got this other pink, and you can see how these colors just kind of start to gradate. Then it gets to this color, which is pretty much right around our 200 millimeter speed. So it actually slows down when we're 3D printing on all of these overhangs. So when things are actually coming out at an angle, that is where it's like we need to slow down just a little bit. And this is what you're determining here. So at these extreme angles, it is slowing down to 10 millimeters a second. And what that's doing is it's giving it enough time to cool while it's moving. And that way you don't have a really bad looking underside. And when it's straight up and down, it doesn't have to worry about that. It is just printing as fast as you tell it to. But when you are got any of these things right here, like any of these under pieces, this can actually help you get a cleaner print by slowing down. Now, the one thing about this is this does slow down your print time just a little bit, but not a whole lot, I've noticed. So if we look right here, this is actually going to take us 3 hours and 38 minutes total to print. Let's turn this off and let's slice it again. So now we've got this sliced again, and it's only 3 hours and 34 minutes. So if you're really worried about speed, having this turned on isn't going to affect you very much, because we're talking that's 4 minutes. It adds 4 minutes to our actual 3D print. Because if you look at those extreme overhangs where it's going 10 millimeters a second, it is a very short distance, so it's not printing it forever. And 10 millimeters a second is still moving. That's like the mouse speed right now, like just that right there. So it does that little short stint, and then it goes back to the full speed, or it goes up more, or it goes faster to accommodate for whatever angle it's at. So generally speaking, this is pretty good to actually have on. But I wanted to do some test prints to see really what's the difference here. So the last thing I want to say about this is I have turned this off, and you can see that there's still blue right here. And that means those are overhang walls, which means it is actually, no matter what, it is going to print slower. So let's go over to our speed, and if you look at there, it is actually going to be slowing it down to 20 millimeters a second. So that color right here, it's anywhere between 20 and 46 millimeters a second. So it doesn't really matter if you turn it off. So if you're turning this off because you're looking for that extra speed, you're not going to be gaining that much, because you can see with some of these different prints, it is actually still going to slow down. But the one thing I will say, look at it. This entire thing is going to be printing around 200 millimeters a second. And you might be wondering, well, why at the top? It's because this is such a small point, and it has to go a little bit slower to allow the filament to actually cool down with the cooling. Because if it's still hot when this next layer goes down, that's where you can get some of those zits, and also it might not actually get the good formation that you want because the plastic is still hot. We need every single layer to be cooled down before we start the next layer. So you'll notice every single time you have like a small point or something, it's always going to slow down. And that being said, you might be wondering, well, then why aren't they on these points right here? And that is because when it's printing these last few layers right here, it's also printing the entire model. So it's giving it plenty of time to cool down before it comes back to get the last few pieces. So it's really always right at the top of your model. So the last thing is I have this overhang test. And this overhang test is actually showing you all of the different angles it can 3D print at. So you can really see the capabilities of your 3D printer to help you understand, okay, when do I really need to put in supports, or when can I get away with not having supports, especially when it comes to different speeds. Because you can get different results the faster or slower you go. So I actually printed a bunch of these just so we could see what it would actually look like when we have our slowdown for overhangs on and off at different speeds. So let's go jump over to the table and I'll show you these 3D prints that I did. All right, real quick, I just have to say, thank you. Thank you to all of these amazing people for supporting me on Patreon this month. And if you want to join my Patreon, you will get exclusive access to my private Discord channels where we talk about everything 3D printing, fixing our printers, those fails that we get and how to avoid them, as well as painting our 3D prints. This community is growing every day and it is awesome. So if you're interested, I'll leave a link below for you. Other than that, let's get back to this video. So the first tests I did was the standard 2mm layer height when it comes to using slowdown for overhangs or without slowdown for overhangs. Now, our first version is I had no slowdown for overhangs. And when we flip this over, we can see our different angles. So we have 40 degrees, 45, 50, 55, all the way down to, or up to 75. Now, when we really look at this, we can see how nice and smooth the 40 degree, 45, 50 degree are. But then when we start getting into 55 degrees, we can really start to see a little bit of an issue. And the further along we go, the more issues we have. And all the way to 75. And you can see the quality of this print when you are printing at a 75 degree angle. So it doesn't look good here. This is where you would absolutely want to add supports. But sometimes you don't want to have supports and you want to see how far your print can go. So when it comes down to it, the big things here are using this slowdown for overhangs or not using it. So the big things here are to decide whether you should be using slowdown for overhangs or not, and at what speeds should you actually be running to get the best results. Now, these are just prints that I did. You definitely want to do some testing on your own, because you might be getting different results too, because it could depend on the filament you're using, and it could also depend on what type of cooling you're using as well. Because I was just leaving this at the default settings when it comes to cooling. And these are so many different factors when it comes to looking at these prints. But I just wanted to show you the results with side-by-side comparisons when it comes to using slowdown for overhangs and without slowdown for overhangs. So if we look at these side-by-side, this one right here has the slowdown for overhangs. This one does not. So no, yes. We can see they both print 40 degrees, 45 degrees, and 50 degrees very well. And anything under 50 degrees, you should always be able to print without supports. It's when you get past that. And it also determines on how far you're printing it out. That's the other thing that I really like about this test print. Now, when we look at 55 degrees, the one that is with slowdown for overhangs did a lot better of a job when it comes to our overhang, because it has printed it very, very nicely. But this one has just a little bit of an issue because it was going the constant speed the entire time. So it actually slowed down for this. Now, when we look at 60, same thing. You can see that this is starting to get a little bit of a ridging and it probably needed some supports. But it actually got away with 60 degrees just fine. And remember, this is at 200 speed, so 200 millimeters a second. Then when we're looking at 65, you can see that it starts to mess up on both sides. But I will say that the slowdown for overhangs does work a lot nicer. Then when we get into 70 and 75, I tell you what, this started to do okay, but it started to get really bad. And then this did okay as well and got really bad at the end as well. So when we get to 75, I think they're both just terrible. Honestly, it's hard to compare two bad things together. But if I had to make a comparison, I think, honestly, this one did okay. It did a little better because you can see a little more warping right here because this is solid. I can't really bend it. So when it comes to our default settings, using slowdown for overhangs, you get pretty good results. And the other thing to keep in mind is look at how nice this actually printed all the way out to here. And same thing here. It actually printed all the way out to here. So if you have something at, say, 65 degrees and it's only coming out just a little bit and then it's going back in, you might be able to get away with just using slowdown for overhangs and not using any supports. Now, the one thing is, this is pushing out. The inwards are also at 65, 70, and 75, and they did all really well. And I would say they did well on all of them except for when we're dealing with the no slowdown for overhangs on the 75 degrees. And that is just, I mean, that is a wicked angle. Now, this is the original test that I did, but I was wondering, if I do different speeds with slowdown versus not slowdown, am I going to get different results? So right now, I would say with slowdown for overhangs is the better option when you're dealing with defaults. So we've got one winner so far for the slowdown. So let's go up. So I did this at 300 millimeters a second, and then same thing, with slowdown with overhangs and no slowdown with overhangs. And if we go through this really quickly, 45, 50, 55, 60 all look good. And if we go 45, 50, 55, and 60, not so good. But if we keep going to 65, this is where they both start to mess up. But slowdown works a little better. And moving on, you can both see right here, they are both just kind of messing up. Like, the further we get out, the worse they actually get. And when it comes to the winners, when it comes to 75, honestly, they both look terrible. But when it comes to these speeds, I would say at 70, my actual top pick would be without any slowdown for overhangs. So it's really just dependent on like your model and what you're trying to print. But overall, I would say using your slowdown definitely will help you. Now, remember, it does affect your time a little bit, but not a whole lot. All right, so then going from there, I decided to go down. So this is now half of what the original speed is at 100 millimeters a second. We have with and we have without. Now, if we look at these, 40, 45, 50, 55, and I would even say 60 all work out really well. Now, we got a little bit of an edging right here, but this one does too. It's kind of hard to tell. And remember, this one doesn't have it and this one has it. So slowing down completely will help you get better overhangs no matter what setting you're doing if you are going up to 60 degrees. Now, when we get up to 65 degrees, I would say still, we are getting close to like, this one is just a little bit worse, but this one isn't that great either right here. And if we keep going, and this one is without the setting, the slowdown for overhangs. And you can see that, honestly, they both mess up. And it's hard to tell which one you think is better. But I would say this one is actually probably a little bit better. Because it's got some ridging and stuff. But this one's got some bubbling and things like that this one doesn't really have. It has maybe a tiny bit, but not a lot. So when it comes to going at 100 millimeters a second, I think honestly, no slowdown for overhangs will get you just as good of a result, if not a little better, because some of these, I just think that this one's a clean winner. So that made me think that speed really plays into it. So then I cut it down another 25 millimeters. So if we flip these over, this one does not have the setting, this one does have the setting. And if we look 45, and if we look 40, 45, 50, and then at 55, we start getting issues. This does not have the setting, and you can see how it starts to mess up. So then when we look at the 60, we can see that this looks nice, and this one not so nice. Then the 65, same thing, but this is really where it starts to fail. And you can see this one starts failing a lot sooner. And when it comes to the 75, I mean, nothing looks good at 75 degrees. But the 70, I mean, this one does look a little bit better. So throughout all of these prints, I've basically come to the conclusion it's not a bad thing to turn this setting on. But if you're going to turn it off, I was getting the best results with, honestly, 100 millimeters a second. Because when it came to this one, the default settings, I wasn't getting really good settings when I was turning that off. But I got better settings when I turned it back on. So these are just some of the things that I thought was worth looking at and seeing, does this setting really help us overall? And my consensus is yes. I think it's wise to have it on. So now that I've shown you that, you might be wondering, why would I ever turn that off if I get better results when I have it on? And this is the key here. Sometimes you'll get 3D prints that have a nice smooth finish, but you're going to notice that there is kind of like this line where it looks super smooth, and then maybe you've gotten something else right here. I don't know if you can see this, but there's a clear line here. When it gets up here, it changes. And what that is slow down for overhangs. It is actually starting to overhang, so it starts slowing down in certain areas. And that's how you can get some of these little effects on your 3D prints. So it's important to understand what's causing this. And it is the slowdown for overhangs. So if you turn it off, you'll be able to remove this because it's a constant speed the entire time. But when you turn this off, you have to be aware that you might actually start getting some overhangs that really needed to slow down. And that's how you can get some of these weird kind of little imperfections in your actual 3D prints. So just keep that in mind when you're 3D printing. So I would say just keep this setting in mind when you're looking at the speeds of your 3D print and what kind of smooth finish you're looking for. Because you might print something out and you get a crazy line across the side and you're like, why? Is it at an angle or is it straight up? Did it actually start to slow down? And that's where going into your settings really do help for you to be able to see where it's speeding up on your 3D print and where it's not. So those are all the basic settings that you need to know when it comes to the speed of your 3D prints. And the slowdown for overhangs, it is a very useful thing to understand because there's certain prints where you don't want to use it. But other prints, I tell you what, it will save you time and it will get you some really nice results. But it's just understanding what it does. So other than that, I wish you a great day and I'll see you in this next video.